Hello everyone, welcome back to my channel. In this video, I'll be discussing about class 8 metals and non-metals. In this lesson, we'll study about physical properties of metals and non-metals and chemical properties of metals and non-metals and uses of metals and non-metals. These are the topics will be covered in this lesson. Now let's get into the chapter metals and non-metals. See, in our surrounding, materials are broadly classified into metals, non-metals and metalloids. But in this chapter, we are going to study about only metals and non-metals. Whatever the things we use, we see in our surrounding is either made up of metals or non-metals. Okay, now let's see what are the physical properties of metals. Metals are generally solids. Most of the metals in our surroundings are solids. Example, iron, copper, magnesium, zinc, silver, gold are the common examples of metals, and we see these metals in our daily life, isn't it? We come across these things in our daily life. Okay, so there is an exception, and that is mercury. It is a liquid non-metal, so that is why we don't say that all metals are solids in nature. There is one exception, that is mercury. Mercury is a liquid metal. Second one, metals are lustrous in nature. That means metals have shiny outer surface. Metals have shiny surface. Example, gold, silver, iron, copper, whatever the metals you take, you can see these metals are shiny in nature, isn't it? You can see a shiny appearance of metals. This is known as lustrous property. Third one, conductivity. Metals are good conductors of heat and electricity. That means they allow heat and electricity to pass through them. Example, copper. We use copper wires in the conduction of electricity. Not only copper, all the metals have ability to pass heat and electricity through them. That is why metals are considered as good conductors. Next property, sonorous sound. See, metals when they hit hard, when they strike hard by the other metal, they produce a ringing sound. They produce a sharp sound that is known as sonorous sound. That is why in the bells and alarms, we have seen that metals has been used in that alarms. Why? Because they produce sharp sound called as sonorous sound. Next property, metals generally show malleability and ductility. What is meant by malleability? What is ductility? Malleability means it is a property of metal is beaten into thin sheets. Property of a metals where it can be beaten into thin sheets is known as malleability. Example, see, we have seen aluminium foils, isn't it? Aluminium foils is used to wrap food items. See, we have seen other articles also made up of aluminium. How are these aluminium can made into thin sheets? Because aluminium has a property of malleability, that is why it can be beaten into thin sheets. Not only aluminium, other metals such as silver. You have seen silver decorations on the sweets, isn't it? Is a very thin silver papers has been used in the decoration of sweets. How we can convert into thin sheets? Because that silver also possesses malleable property. Not only aluminium and silver, all the metals have a property of malleability. That means it can be beaten into thin sheets. Next one, ductility. What is meant by ductility? Ductility means drawing a metal into thin wires. Just now we have seen thin sheets. Now ductility means drawing a metal into thin wires is known as ductility. See, we can see malleability and ductility only in case of metals. We cannot apply this, we cannot see this property in any of the substances other than metals. Okay, see, ductility means it is a property of drawing metals into thin wires is known as ductility. Example, copper wire, which is used in conductivity of electricity, and also tungsten which is used as a filament in bulb. It is also a metal. It is highly ductile metal. It can be drawn into very thin wire. So tungsten have very good ductile property. This is all about malleability and ductility. This is about physical properties of metals. Now let's see physical properties of non-metals. When it comes to physical appearance of non-metals, most of the non-metals are gaseous in nature. Most of the non-metals are gaseous in state. For example, oxygen, hydrogen, nitrogen, argon, krypton. Okay, these are all non-metal. These are all example for non-metals. These are all in the gaseous form. Next property, lustrous. Non-metals are non-lustrous in nature and they do not produce sonorous sound. So in case of metals are sonorous and lustrous. Non-metals are non-lustrous and non-sonorous in nature. Third property, conductivity. When it comes to conductivity, non-metals are bad conductors of heat and electricity except graphite. Graphite is a non-metal but it is a good conductor, whereas other non-metals are bad conductors of heat and electricity. Malleability and ductility. Non-metals do not show malleability and ductile properties. Only metals will show these properties. Non-metals do not show malleable and ductile properties. This is about physical properties of metals and non-metals. Next is chemical properties of metals and non-metals. See, what is meant by chemical properties? Chemical properties means how do metals and non-metals react chemically with the water, oxygen and acids and bases. Understood? See, how do these metals and non-metals react with oxygen, water and chemicals such as acids and bases will decide the chemical properties of metals and non-metals. First, we'll see reactivity of metals with water is not same for all metals. It will vary from metals to metals. For example, potassium and sodium are highly reactive metals. So they are stored in the kerosene or paraffin wax because they react vigorously when they come in contact with oxygen or moisture. That is why they are stored in kerosene or paraffin wax. Metals react with the water. They form metal hydroxides. Metal plus water will give rise to metal hydroxide plus hydrogen gas will be liberated out. Example, sodium plus water give rise to sodium hydroxide plus hydrogen gas will be liberated out. This is one example of metal plus water. And when it comes to non-metals, non-metals do not react with water. Non-metals will not react with water at all. So, no reaction of non-metals with water. But non-metals react vigorously with the oxygen. Example, phosphorus. Phosphorus is highly reactive non-metal. It reacts vigorously with the oxygen. That is why phosphorus is stored in the water. Next is reactivity of metals with oxygen. See, this process is also called oxidation. When metals react with the oxygen, they form metal oxides. We have different names for this oxidation of metals. One is rusting, tarnishing. These are the names called to metals which are undergoing oxidation. So this is also called corrosion. When metals come in contact with the oxygen, they will form metal oxides. This process is also called corrosion. The metal will undergo corrosion. When you see the nature of metal oxides are basic in nature. For example, if you burn magnesium ribbon, magnesium is a metal, magnesium ribbon is burnt in the presence of oxygen, will get magnesium ashes, isn't it? That is magnesium oxide. Mix that magnesium oxide in the water and test with the litmus paper. What is the use of litmus paper? Litmus paper is used to test whether a given magnesium powder mixed with the water, that litmus paper turns to blue color. That means oxides of metals are basic in nature. What is the nature of metallic oxides? Metallic oxides are basic in nature. What about non-metallic oxides? Non-metallic oxides are acidic in nature. Acidic nature. We have an activity to show that non-metallic oxides are acidic in nature. Take a sulfur powder and burn it in the presence of oxygen. Then sulfur dioxide gases will produce. Shake that sulfur dioxide gases with the water and test that water with the litmus paper. That water which has sulfur dioxide in it, it converts litmus paper into red color. It turns color of litmus paper to red. This shows that non-metallic oxides are acidic. Metallic oxides are basic in nature. Here, reaction of metals with oxygen again varies from metals to metals. All metals do not form oxides. Only few metals, reactive metals, will form oxides very vigorously. Some do not form oxides at all. For example, gold, silver and platinum. These are noble metals. They do not form oxides upon reacting with oxygen. They do not react at all. They are noble metals. Next is non-metals. Non-metals react with air, I mean to say oxygen. They do not react with water. Next, reaction of metals with acids and bases. Metals reacts with acids to form salt and hydrogen gas. For example, take a metal zinc plus hydrochloric acid. Put zinc metal in hydrochloric acid, we'll get zinc chloride and hydrogen gas will be liberated. Take one more example, magnesium plus H2SO4. Magnesium is a metal, H2SO4 is concentrated acid, that is sulfuric acid. When you add magnesium ribbon into sulfuric acid, it gives rise to magnesium sulfate, that is salt, plus hydrogen gas will be liberated out. Same thing in case of bases also. If bases come in contact with metals, they also give rise to salt and hydrogen gas. Example, sodium hydroxide plus zinc will give rise to sodium zincate plus hydrogen gas. Now sodium zincate is salt plus hydrogen gas will be liberated out. This is what the reaction of metals with acids and bases. Next is displacement reaction. What is meant by displacement reaction? See, it is a type of chemical reaction in which highly reactive metal displaces least reactive metal from its salt solution. This is known as displacement reaction. See, in order to know the displacement reaction, we have to learn reactivity series. Reactivity series in the sense it is a series of arrangement of elements, I mean to say metals, in decreasing order of their reactivity. In this, metal placed above are highly reactive. They can displace the metals which are present below them. So, for example, potassium and sodium. See, among these two, potassium is highly reactive than sodium. It can displace sodium, but sodium cannot displace potassium because potassium is highly reactive. Let's take one example for displacement reaction. Iron plus copper sulfate. Iron is a metal. Copper sulfate is salt solution of copper. If you put iron nail into the copper sulfate solution, copper will be displaced by iron. Iron will displace copper. So, ultimate products will be iron sulfate plus copper. Copper will deposit on iron and color of copper sulfate will also changes. Earlier it was a pale blue color. Now it turns to, after reaction, it turns to green, pale green color. This is what about displacement reaction. Next is uses of metals and non-metals. Metal like iron is used to construct buildings, bridges and roads. It is used in the construction purpose. Next, metals like copper, aluminium is used in the electrical appliances in order to conduct electricity, and also metal sheets such as aluminium sheet, iron sheets are used in various fields. Uses of nonmetals. Chlorine is used to kill germs. Chlorine is also non-metal which is used to kill germs. I mean to say, you have heard about chlorination of water. In the chlorination, we'll add chlorine to the water in order to kill germs. Non-metal like oxygen and carbon dioxide is used in the respiration. Oxygen intake by animals, and carbon dioxide is intake by plants. So oxygen and carbon dioxide are non-metals which helps in the respiration. And nitrogen and phosphorus are used in the fertilizers which increases fertility of soil. So nitrogen and phosphorus both are non-metals which are used in the fertilizers. Next, iodine. Iodine is also a non-metal which is used in antiseptic. These are the uses of metals and non-metals. This is all about metals and non-metals chapter. If you like this video, please do like, share and subscribe to my channel. Thank you.